In this image, we're visualizing something that you're probably pretty familiar with already. So if you were to take a lump of sugar and you were to drop this in a glass of water, those sugar molecules are going to gradually spread out, and we're going to end up with the sugar completely dissolved in the water, or what we would then call sugar water. What we're really looking at here, if we apply more proper terminology to it, is this is the process of diffusion. Diffusion is the tendency of any substance, not just the sugar that we're looking at here, but of any substance to spread out and occupy all the available space. So in other words, once we drop that lump of sugar into this glass of water, that lump of sugar now has a whole glass of water that it can spread out in, and that's what it wants to do. Another way that we can look at this is that when we look at our sugar right here, it is very highly concentrated. So those sugar molecules are very, very, very close together. And then when we look at it over here in the glass of water, at this point, it is at a low concentration. So diffusion is the tendency of molecules to want to move from a high concentration to a low concentration. So the molecules are going to spread out so that they do get to that low concentration. And when they take up all of the available space to them, what they are doing is they are reaching the lowest concentration that is possible for them in that given circumstance. So here's just another example of this. Notice that in the top picture, the red molecules are at a high concentration. So in other words, they're very close together, very tightly packed. And in the middle picture, they're not as concentrated. And in the low picture, the bottom picture, they are at a low concentration. So if we were to start with molecules that were highly concentrated, if given the opportunity, so if they had all of that space available to them, those molecules will gradually spread out until they get to the situation that we see on the bottom here. That's diffusion. Now, a couple things to understand about diffusion. This is going to be a type of passive transport, and it is passive because these molecules, in this case, the red molecules here, they are going from high to low. Another way to say this would be that they are going down their concentration gradient. So that's just a different terminology to use for the fact that they are going from a high concentration to a low concentration. And because this is passive transport, this is going to require no energy. Another thing about it is that each of these molecules, these red molecules, are not just making this massive dash to the other side of this container that they're in. So they're not just all running outward to get to this very low concentration. Instead, what's going to happen is that each molecule is going to be bouncing around in different directions. Some will actually be bouncing back towards the middle. And so we want to keep in mind that each molecule is going to move randomly. But as each molecule moves randomly, the population of molecules spreads out. Okay, so the population is going to be moving towards that low concentration, but each molecule on its own is just kind of bouncing around. Another key point is to understand that once we get to this bottom picture, these molecules are still bouncing about. So they don't stop moving. They're still moving, but we don't start to see those concentrations really change anymore. And while I'm just labeling the red molecules, the blue molecules would also be bouncing around and they would be moving as well. There are a lot of different things that can affect the rate of diffusion. One of those things would be temperature. So as temperature goes up, molecules tend to move more rapidly. So if these molecules were bouncing more rapidly, we would expect the diffusion process to take less time, because it's going to be much quicker that they go from the area of high concentration that you see in the first picture to the area of low concentration that we have on the bottom of this diagram.